you understand what I did here?
That's equal to 0.
This is not equal to 0. This is plus.
Plus, but that's j squared.
Yeah, j squared is negative 1 squared, right? It's positive 1.
No, it's a square root of negative 1, isn't it?
Oh, it's yeah,
One
square
minus
root of
one.
that.
There shouldn't be one
You
minus
should have
j
just pulled the
squared.
1, not the j.
Oh,
The component, not
yeah,
the j.
Yeah.
It's minus j squared.
Yeah, minus
One
j squared.
minus
Yeah,
j
minus j
squared.
squared. So,
There you go.
And then it's one, yeah.
okay. So you can just find it by p square over 10.
So just 50, so just 50
Yeah.
over 10.
Yeah. And then you might not get this question because this is from the circuit analysis, but it's like a fundamental one. So the next question is, it says the 50 Hz induction motor, the shaft is plugged. So that means what the slip? If the shaft is plugged, which means it's not rotating. So slip is 1. So slip is 1. And the starter line to line voltage is given as 190 volt. So you have to remember one thing. So whenever you are looking at the, like, it is not important for this question, but the other big questions. So whenever you are watching the voltage, whatever is given in the question, that's always line to line RMS. But when you are solving the equivalent circuit in induction motor, it's always in phase, per phase. So whatever the voltage is given here, you have to change it to per phase. So to change it to per phase, you have to divide by square root of 3. So remember that, because that is one mistake like most of us do, like forget it. Okay, what is given here? So you have 50 Hz induction motor, and it says when the motor is stopped, it's not rotating. When it's blocked, it says the input voltage is 190 volt, but the rotor winding induced voltage is 19 volts. So what's the transformation ratio for this? 10. Yeah, exactly. Then it's asking you what is the rotor winding voltage if the slip frequency is 10 Hz. Yeah, done.
Sorry, if I can just go back to question 1. Sorry.
Question 1.
Yeah, question 1. It's just 50 and not 50 squared.
It's 50 squared over 10.
50 squared.
So what is this one? Okay. So can you find the slip from this when it gives the slip frequency is 10 Hz? So what is slip frequency? So when you hear the term slip frequency, what is the meaning of that? The meaning is if we have an input frequency of 50 Hz, then the slip frequency should be slip times the input frequency. So is this okay? It's not visible. Let me. Okay, is this visible to everyone? This side. So if your input frequency is 50 Hz, then what is slip frequency?
50. This slope is 1.
No. You see here, I'm just asking the definition of this.
Oh.
Yeah, it will be 50 for the first part, but I'm just asking definition. Definition is what?
Oh, so
It's S times slip frequency, right? So it's given that when the motor is running, the slip frequency is 10 Hz. It says when the rotor winding is induced, if the slip frequency of the rotor circuit is 10 Hz. That means it's given the slip frequency is 10 Hz, which is equal to slip times what is the input frequency? It's 50. So now you find the slip, right? The slip will be 1/5. So once you find the slip and you know the ratio is 10, you can find the rotor winding voltage. Is there any question for this? So do you understand how do you find the rotor winding induced voltage?
So can you go with that? What's the next step after this?
Okay, so you have the slip now, and you know that, what is that called? NR over NS is equals to 19 over 190. That is equal to 1/10, right? So this is the winding ratio. So now when you want to find the rotor voltage, so V rotor, so just remember how do you do it in transformer. So V rotor should be equals to NR over NS, which is 1 over 10, times V input. What is V input? V input is 190, right? Times slip. So whatever you do use in transformers, so you just use the transformation ratio. So the only difference is in induction motor you use slip. So then you multiply the slip here. So that will be the answer. So you should get 3.8 for this. Is it clear? Is it visible?
Yeah.
Or do you want me to write in the paper?
You can actually put that thing up and then that way you can write it.
Okay, yeah, okay, I can do that.
Oh, yeah.
Okay. So this one is clear to everyone, right? Second question. So let's go to the third question. It's asking you, so it's asking you that there is a AC machine. We don't know if it's an induction machine or a synchronous machine. It's a AC generator, and it says the machine gives a output power of 1 megawatt at a power factor of 0.9 lagging. If the output power is 1 megawatt and the power factor is 0.9 lagging. So it's asking you, can you find if it's an induction machine or a synchronous machine? Is it possible to find using just this one, just the power factor and the power? So what is the property of an induction machine?
Well, it's not going to have the same speed as the
Yeah, but I'm asking you with respect to the reactive power, because from this you can find the reactive power, because you have the power factor and you have the power.
false.
It should be true.
Well, it's true because
because the induction generator, it will never give reactive power. It will always accept reactive power because it's always the inductor. It's induction generator. It will always accept the reactive power. So because it's a generator, so if it's a generator, what is the direction of the current? Always outside. It's always outside. Yeah, key is it's a generator. So you have a generator, so the power goes outside. And now let's find the reactive power for this. So it's given P is equals to 1 megawatt and power factor is 0.9, which is equals to cos of theta, right? Power factor is cos theta. So how do you find the reactive power Q? Q is equals to S sin theta. S is the apparent power. So you can find S directly by using P over power factor into sin theta, right? Because you know that S cos theta equals P. So power factor is given as 0.9. So P over 0.9 into 1 minus 0.9 square. You understand this part, right? Why do I do this? Because 1 minus sine square, 1 minus cos square theta is equals to sine square theta. So I want sine theta here. So I have the power factor, so you can directly use that to find the sine theta. You don't have to actually find the theta and then solve it. So, and square root. So you know that, so what is 0.9 square? 0.18, right? 0.18, sorry, 0.81. So this part is positive. That means the whole thing is positive. So, which means Q is positive. So Q is positive means this thing is giving reactive power. But we know that the induction generator cannot give reactive power. It will always accept reactive power. So from this, you will find that it's always synchronous generator. So you are able to find if it's induction or synchronous. Then let's go to the next one.
So just to clarify, synchronous machine will give out. Yeah.
Synchronous machine can do both. It can accept or give out.
The induction.
But induction will always accept.
Consuming.
Yeah, consuming reactive power. This one, it says AC machine. Okay, who can answer this question? Goes with the question. It's done multiple times in the class, so, or at least tell the steps of how to solve it. It's an optional question, but you can say how to solve it. How do you know it's... So what is the relationship between torque and angle? Because the only thing is given is the angle. He says everything else is constant. The only thing increases is the angle.
It's sine.
Sine of the angle. So torque is proportional to the sine of the angle. So it's given that the angle increases from 30 to 90. So the only thing you have to do is what is sine 30?
1/2.
Is 1/2. And what is sine 90?
1.
So it will be doubled. So the only thing, so in this course you have multiple formulas for torque. So usually don't get confused of using some very complicated formulas. So see how can you can do it easily. Like for example, in here you saw the angle, so you can just find the relation between torque and the angle, and you can solve it easily.
When you said torque is going to double?
Yeah, because this torque is sine theta, so it will double.
So it's 1.
It says the 8-pole induction machine has a rotating speed of 810 RPM. The starter voltage has a frequency of 60 Hz. The frequency of the rotor voltage. This is easy. Do you know how to solve it? It says what is the rotor frequency in Hz for the rotor side. So how do you find the rotor frequency? It's just slip frequency, right? I just told you there. So it's just, so rotor frequency is S times input frequency, right? Or slip times.
So what's your frequency?
So we get 120 over the number of poles times
Frequency.
the frequency, and that's going to get us the synchronous speed.
Yeah, so you'll find the NS first, which is 120 F over P. It's given 8 pole, and it's also given the rotating speed is 810.
So then we get NS minus the rotor speed
Yeah.
over synchronous speed, and that's going to be our slip.
Yeah, so this is the slip.
So our N is the 810, right?
Yeah, NR. So 810. It's what is this? It says the induction machine is rotating at a speed of 810 revolutions per minute. That means the rotor speed is 810. And then the synchronous speed you can find it from the number of poles,
Isn't it
which is
over
120 F over P.
But isn't it over synchronous speed?
Yeah, it's NS.
And then now that we have everything, I think we can go and resolve it.
So, any question here?
So we solved for the slip.
So you know the final formula is this one. The unknown is the slip. So you have to just find the slip, then you can find the rotor frequency. So from the slip has only one formula, which is ns minus nr over ns, or
We could also just do, I guess that would be 900 RPM for 60 hertz, right?
yeah.
So you would do 900 minus 810 over 900, and it's the same thing, but you still take that slip. What would be your F in and is it 900 or 810?
F in?
Yeah.
F in should be 60 hertz. It's frequency in hertz. This 900 what you found here, this is in RPM. Even this is in RPM.
Yes.
But the frequency you have to find it in hertz.
So is it 6 hertz?
You see, it is 6 hertz. So you have to always remember that the speed is always in RPM. So you remember in one of the question in the homework or in the quiz, it was asking you to find the speed in RPM or hertz, right? In one of the homework, one of the quiz, I think. I don't remember. It was a quiz, yeah. So in that, so to transform from RPM to hertz, you just have, so if you have like 900 RPM, to convert it into hertz, you can just do 900 over 60. Because this is RPS. So hertz is same as RPS, revolutions per second. But usually you don't have to convert it, you can just use RPM and solve it. Because, and then, yeah. Or let's try this. So this one everyone understood this process, right? How I did this. Suppose I want to do it in hertz. So you can also calculate the slip using hertz. So you have 60 hertz is already given in the question. So which means you can write omega. So another formula is omega s minus omega r over omega s is equals to ns. So omega s is for 60 hertz. So you can just write 60 here. And to find omega r, you can write 810 over 60. So what is 810 over 60? Can you find this value? What is 810 over 60?
13.5.
13.5?
13.
13.5? So did you, okay, can you find this one? 13.5, 6, t minus 13.5 over 60.
0.775.
0.775. Times 60 is how much? No, it should be 10. It should be 0.75. Because if it's 6 hertz, then sleep should be 0.1, right?
And what's that's in rad seconds, isn't it?
We just forget about this. I have to, just you can do using this process. This is not giving the right answer. But it should be, if I can find it, I'll post it in the solution. But you can just use RPM to solve it. You don't have to use like RTS. Is this clear?
Was the answer 6?
Yeah, the answer is 6. Let's go to the next one. So what is this question? Within transformer. So this is not. 4-pole induction generator based wind turbine is connected to a 60 Hz grid and the output power is 1 megawatt. It says the rotating speed is 1890 RPM.
Are you doing G?
Yeah, because this is transfer. This is on transfer.
Oh, okay.
The rotating speed is. Pardon?
Inside Brian transformers?
No, I don't think you'll have transformer in there. It's just synchronous machines and induction machines.
Oh.
Suppose we can. Okay, it's asking you to find the mechanical power. So, do you guys remember the diagram where I described the power transfer for the induction machine? So, if you have so this is the equivalent circuit of an induction machine. So suppose you have the input power here. Then you have the starter couplers P. Then this is. Then you will have a rotor couplers P core loss. Then this will be what? So this power will be the air gap power. Then you will have P rotor. Then this will be P shaft or P mechanical. So this is one you have to always remember when you're doing the induction machine. Like if you have something like question is asking me about power, then you have to discuss about. So you have to find the P shaft. So, what is the mechanical? What do you mean by mechanical power? It's nothing but the shaft power, which is at the end. So, if you just look at this, so you know that power is always related to the resistance, right? So, this shaft power is always related to R2 times 1 minus S over S. Yeah, so I'll explain that. So in the class we are told that this is, I'm just drawing the rotor side. So we have something here, then we have, this is R2 over S, and this is JX2, right? So this is what is the equivalent circuit of induction. This is also correct. So when I do this, you can see this is P air gap, right? So what is P air gap? It is 3I squared R2 over S, right? So this is just related to this. So then we subtract the P rotor from there. So what is P rotor? Is 3I squared R2. It's just because of the resistance. So the P shaft should be equals to P gap minus P rotor. So in this equivalent circuit, I have separated the R2 and I put here R2 into 1 minus S. If you add both of them, you will get R2 over S. Just to make sure this one makes sense with the circuit. Okay, so it's asking us to find the mechanical power. So what is P mech? equals to I square R2 into 1 minus S over S. This is from the here, like just this is the mechanical power, the output power. So just analyze this. So it is 3 I square R2 over S times 1 minus S, right? I can write it like this. So what is this part?
B gap.
P gap. So you can just write it as P gap times 1 minus S. Right? Or we can also write it as P rotor times 1 minus S over S. Or P loss, you can write it as P core loss. Like into 1 minus S over S. Because you see here, so what is this one? This is just P rotor, right? P rotor, P loss. So you can just write P loss into 1 minus S over S. So now you have to find which one is given. So you can see the output power is 1 megawatt. Is given. So what is output power? Output power is nothing but whatever the shaft power is there, you remove the rotor power. So it's just P air gap. So the output power is P gap. So P gap is given. So this one, what is given here, is P gap.
So we always consider.
Output is always P gap. Yeah.
But why is it not P shaft?
No, P shaft is the total power you are getting at the output. But after that you will have the losses. So you have to remove the loss, then you will get the output power. Yeah. Because you know this is the actual equivalent circuit of induction motion. So if you want to find the output power, this is the output power. So now you have P gap. So which formula we should use? We should use this one because we know P gap. We just have to find the slip and then we'll find the P mechanical. Right? Does this look too complicated?
Is the reason we're using P gap and not P shaft because it says we can ignore the losses?
It says suppose we can ignore the loss at the starter winding. That means it's saying we don't have this loss. But you don't have to use this loss anymore because you can see the P gap is directly given here. So the output power, whenever it's given the question, that is always equal to air gap power.
When is it equal to P shaft then?
P shaft is not the output power, it's the total power. So when you remove the loss from P shaft, you'll get the air gap power.
Okay.
So you have P gap here, and it's given that the induction machine is rotating at a speed of 1890, and it's a 4-pole 60 Hz induction machine. So you can find the slip from there, right?
So how do you know which one is on P gap and which one's P out and when it's P out?
P out is always P gap. The output power is always P gap. And the mechanical power is always the P shaft.
You said that the power of the shaft is total power,
It's total power.
but you subtract rotor power, P gap, so P gap is total power.
The P gap is the output power. Like how much you are, like, for example, if I have a induction machine and so how much you measure at the shaft is the, what do you call that? Okay, so how much you measure at the output of the induction machine, that's what you get it here, which is P mechanical. That's the mechanical power output. But whenever you remove the loss, so this is the mechanical power. So your question is that?
Referring to the shaft power as the total power.
Okay. So this mechanical power is the power due to the shaft. So the mechanical power is equal to the shaft power. So how much you're getting at the output? Do you get what I'm saying? Like if you have an induction machine and it's rotating at a speed of 800 rpm, then the power generated by the shaft is the shaft power. And P gap is because of the air gap inside the motor, because it's between the rotor and the starter because of the air gap. So how much power is transferred from the rotor, from the starter to the rotor? So we have an induction machine here, right?
It's made of P.
We have an induction machine here. So this is the starter and this is the rotor. And we know that the energy is transferred from starter to rotor by induction. And that energy transfer depends on how much air gap is there between the starter and the rotor, right? So this energy transfer is called the air gap power. So you have the, so suppose if I go back here, so you have the starter power here, then because of the core of this, there will be loss in the core loss, which you call it as core loss. Then after removing the core loss, that's the power how much we transfer from the starter to the rotor. And once we are in the rotor, then we'll have the loss due to the resistance here, which is R2. So we'll remove the R2 from here, and then we'll have, so once you remove the R2, you will have the, what do you call that? The mechanical power. So, yeah, so, am I clear or any confusion?
So like once you find slip, you can plug that into stuff for P gap and then we'll find P max.
But am I clear in this one or
Yeah.
any question?
Go ahead.
Okay. So,
Is the answer 1.05?
1.05? So your question is still why we call it as P out, right? Why we consider P out as P gap, and why we don't consider this one as the P output, right? So basically P out means how much you can get in the rotor. Mechanical power is actually the real output of the machine.
Okay, so, output power is always gonna be power available to the rotor.
Yeah.
Mechanical power.
Will be the how much is,
whatever is left over after the loss.
yeah.
So you said P shaft is P out minus P loss.
P shaft, right? Yeah, P shaft is always P out minus P.
So is P loss the same as P rotor?
Yeah.
Okay.
So basically P rotor is nothing but loss due to the resistance R2.
So that's always true. P rotor is equal to P.
So, how do you know when you have the B loss?
P loss is nothing but P rotor.
So it's always there with the B gap.
Yeah, it's always there with the big gap.
So why that you know that the output power gonna be only P gap, but not the P loss?
No, P loss is the loss. It will not be the output. It is the loss due to the resistance.
Yeah. So is it gonna be supposed to be like B gap gonna be minus B loss gonna be B mechanical, right?
Yes.
So how you know like is it 1 megawatts? That's the B gap or like?
Yeah, that's the P gap. How do you know that's the P gap? That's the question, right?
Yeah.
So when you have the output power as 1 megawatt, that's nothing but this one gives how much power is transferred from the starter to rotor. So when you look here, so the output power is how much you transfer the power from the starter to the rotor. The mechanical power, which is given, that's what you measure at the shaft. Like if it's a rotor and it has a shaft, the mechanical power is that. Do you understand what I'm saying?
You say that that's like the power of the shaft, not the.
P shaft is always the mechanical power.
Yeah, yeah, I got it. But like, why like, how you know like the output that the just the B gap, not the B rotor?
No, P rotor can be the output. P rotor is the loss. See, if we have a electrical, this is the electrical equivalent of the circuit, right? So if we have a source here, which is V volts, and there is the inductor here, and there is resistance here, and there is a load here, right?
Yes.
So to find the power here, if you have an input power of P in, and this is the P out, then P out should be equals to P input minus the loss at this place, right?
Mhm.
Minus I square R2, I square R, right?
Yeah.
So this is the same thing. So our desired output is at this place, at the output, or at the mechanical power end. So to get the desired output, if we have the power here, which is P gap, and we subtract this power, which is P rotor or P loss, then only you'll be able to find the mechanical power.
So we're just looking for P-mac, not P-rotor?
P max is mechanical power,
Okay.
which is just P shaft, which is this one at the end,
Yeah, so,
the final output.
yeah, so what is this, one is the mechanical power that drives the rotor, that's P-mac.
Yeah. You understand what I'm saying?
Yeah.
So basically, this is the loss. So we are removing the loss, and we'll get the actual output.
So that's why that's one that you remove the loss already, right?
Yeah, this is after removing the loss, and this is the output power with the loss.
Okay.
So this is not what we are seeing at the output of the generator. This is what we are seeing at the output of the machine. So when it says the speed is 1890 RPM, that means the mechanical power used to generate that speed is this. Is it clear?
Yeah. Yeah, kind of.
So all you do then for this one is take 1 megawatt and multiply by
196.
yeah, 196. And you can find the S from this 60, turn that into RPM.
Yeah. How much is the answer? Yeah, that's okay, what's the next question? Any question in this?
The question's good, Martha.
I think this exam, if you just go through the homework, like the only thing you have to be clear is when you use what formulas. So it's an open book opener, so everyone knows that, right? So you should be able to find the formulas.
Unlimited amount.
I think
One
he
binder.
said
Yeah, one binder.
one binder.
So how many problems should we expect from the homework 6 for us homework?
I don't know about that, but I think you should have 3 questions or 4 questions for 2 hours. So it's 2 hours, right? So you should have 4 questions, so 30 minutes each. And there should be one question which is like short answer questions, like you can just look at like these questions. You can just look into the question and find the answer.
We're expecting the first question.
So look and do it.
We're expecting the first question to be like all these parts, the multiple choice, and the other 3 to be free response.
Yeah, the 3 will be like long questions. Not too long, but it's like conceptual questions.
Have you by chance seen the exam? You just talked to her about what she's going to do for the exam?
Yes, it's all synchronous machine learning.
So not chapter 4?
No, but you may get few questions related to chapter 4. It's not like from the chapter 4, but because that's rotating machines and synchronous machines also rotating machines. So it's like related topics.
Okay.
So you may expect something from chapter 4, but not completely deep core into chapter 4.
But not and not from the before the
Not
midterm.
from before.
Okay. That's
What's
fine.
the weight of the final?
What?
35.
35. That's a lot.
Check that.
This is terrible.
That's a lot.
Even though it's only
We can go to the problems.
One of like the short answer ones.
Yeah.
Go to one of the long ones.
Yeah, this. Can you answer this question?
Which one? Okay.
J. You don't have to calculate it. Just look at the question.
That's a nice name.
It's multiple choice question. So, like you have multiple answers. So what it says? It says the wound rotary induction machine has its rotary resistance R2 increased. So which statement is true? First statement is about maximum torque. So what is the condition for maximum torque?
When
R2 R2 over S
Equals
equal like
X equivalent plus X.
R2 plus GS2.
Yeah, so you can just write it as R2 over S equals X equivalent plus X1, X2, right?
Two.
So even though the R2 increases, this will not increase. So it doesn't change. So you can see R2 increases, the machine maximum torque will increase, is false. So even R2 increases, the machine will have same maximum torque. So this is true. Then what does it say? When R2 increases, the startup torque will increase. So what is startup torque? What is the slip at starting?
Here.
1. So you can see the torque is just proportional to, so if you just write the equation, it's like VQ square over C square times R2, right? Because it's I square R2. And slip is 1. So it's just dependent on R2. So if R2 increases, torque also increases. So it will be 3. And then the third question is, when R2 increases, the maximum torque will reach at lower speed. And the sixth is R2 increases, the maximum torque will reach at higher speed. How do you analyze that? It's still going to the maximum torque. So you have to go back to this. You know that R2, so we know that this is constant, right? So R2 over S is constant. But in the question says R2 increases. So if R2 increases, what should be the slip? Increase. Right? So slip increases. What is slip? Slip is nothing but Ns minus Nr over Ns. Right? So if slip increases, Ns is constant, what happens to Nr? Decreases. So that means it will reach maximum torque at lower speed. Is it difficult?
Yeah.
You want that?
Oh, it's
Let's go to the longest question. Okay, first one. Compute the mechanical power. So what does the question say? It says a 60 Hz 6-pole Y-connected 3-phase induction machine is rotating at 1120 RPM, and it says the mechanical load is 10 Newton meters. So what is this? What is this part?
R.
Torque. So mechanical torque is given as 10 Newton meter, and it's asking you to find the mechanical power. Can you find it? What's the relation between torque and power?
Power over omega time.
Yeah, omega E. Omega E. It's always omega E. It's always omega E.
Omega E is the base
Synchronous.
frequency,
Yeah,
right?
base frequency.
The one at like the 60 hertz or whatever.
Yeah.
Or the one that achieves.
So omega E is always equals to 2 pi Fe, which is 2 pi times 60 hertz.
Unless it's like specified as it's like a 50 hertz
Yeah.
motor. Okay.
So,
Can you give me more information?
pardon?
I have it in here as P mac over omega m.
There should be always omega e
I have omega E too.
I thought that's what Professor gave us.
in the class.
I think so. I'll take it. This one's so 1 over 5, right?
Which one? This one?
Yeah.
No, the,
Oh,
Yeah.
sorry, that's the torque.
Torque,
Yeah.
yeah.
Multiply it.
no, this is linked to the class.
Yeah, that's also.
Yeah.
Oh, it's just
P-mac
omega
is
m.
omega E times T-mac.
Okay, so we're using.
It should be all. Okay, let me check the accumulator here. Is it clear?
I assume you're gonna cut out the equation.
Yeah, I can write the equation here.
Yeah.
So what is torque? Torque equals to P over omega E, right? So T mechanical, which is equals to, so when you find the torque, sorry, power, which is equals to T times omega E. So what is the torque? It's 10 Newton meter. So 10 times is 377. Oh no, yeah, you're right.
Mechanical?
Yeah.
Mechanical?
Mechanical. I was just checking that. So, I'm sorry. So, this one should be, yeah, that's P gap will be electrical.
Yeah.
Yeah. So, P mech, so T mech equals P mech over omega m. So what is the omega m in this case?
1,120 revolutions.
Divided by 60. So
Oh, yeah.
omega m will be, so omega m will be 1,120 divided by 60.
Really? Times 2 pi?
Yeah, times 2 pi. So this will be the omega m. So the T mechanical is given as 10 and P mechanical you have to find, and omega m is 1120 over 60 times 2 pi.
I got 117.
It should be okay. So P mech would be 1173.
Uh,
1173. 13. 1173.
117 times the omega, or is it no, times torque.
Yeah, times torque. So yeah.
Times
so,
torque,
so that was right.
It's 117.
So it will be into 10. That will be 1173 watts.
The 1120 in the formula must be
So
1120.
I'll write the other formula here. So T gap
120
is equal
NR.
to P
It's an NR, it's the road.
gap
Yeah,
over omega
and
E.
it's oh, what is the motor? She asked like 120. That's the NR or NS.
This is the NR.
It's NR.
Whatever is given in the question, it says the induction machine is rotating at a speed. So the rotor speed is NR, which is 1120.
Okay.
And from that, you find the omega m, which is over.
So the answer is 1.1.
No, 1173 watts. Compute the sleep, total rotor couplers and total air gap power. So you can find the sleep from here. Can you find the sleep from here?
Yeah. You have the, you can find synchronous speed, and you're already given an R.
So you can find the sleep, and it's asking you to find the rotor couplers, which is P rotor. What is the formula for this?
That is
Three.
3I square R2, right? There's the rotor couplers, and it's asking the total air gap power, which is P gap, is equals to
3 I2 square R2 over S.
over S. So now we have, so what is known to us? Pmac is known. What is Pmac? 3 I2 square R2 times 1 minus S over S. Right? Because Pmac equals P gap minus P rotor. From there you can find this formula. What is Pmac? Pmac is P air gap minus P rotor. So which will be equals to, if I take 3I2 square R2 common, it will be 1 over S minus 1. So you'll get this formula from there directly. So how can you find P rotor and P air gap from this? So you can just substitute this one. What is this part? It's nothing but P rotor. Instead of 3I square R2, you can just write P rotor. So you can write Pmac equals P rotor times 1 minus S over S.
That's always true, right?
That's all.
So you said to find the slip, we're gonna use the 60 hertz with 6 volts to get the synchronous speed. And we have the motor speed, which is 1120. And when we find the slip, just plug it in to find the speed.
Yeah. So you can find the, yeah, exactly. So you can find the sleep from here because you have the 6 pole and 60 hertz. So once you find the sleep, you can find the Pmac. You know the Pmac, so you can find the P rotor. Right? Any question? Then what is P gap? You can find P gap from here directly, or you can also do it like this. P.
B max.
Yeah, you can do that too, directly.
What?
So to
B
find
gap
P
là
gap,
B max plus B rotor.
Okay.
so from this you can find P gap as P mac plus P rotor. Is this clear? Let's go to the next one. Because this question is good. But the questions are not difficult. Do you think it's difficult? Yeah, so you have to just be familiar with the equations and you can do everything, right?
So we're still gonna have to solve for I2 in that one, correct?
I too.
Because the only one that we can get without needing to do any like circuit analysis is the P rotor, which is, oh, never mind, so we have P rotor.
Yeah.
Okay.
Okay. next question, because we have one. So it's asking you to find the maximum sleep at the maximum torque. So what is the condition for maximum torque?
Impedance matching.
Yeah, so it's just R2 over S is equals to X equivalent plus X, right? This is the condition for maximum. But in the question, is it given anything?
It's given in the question, the values of all of that stuff.
Okay, it's given X1, X2,
Yeah, it's
So here you have to do the equivalent circuit because it's asking you to find X max and you don't know X equivalent. This is X2 and this is R2. So if I just draw the circuit, what is it? It's just JX1 and this is JXM.
Oh, no.
Doesn't it give it to you as the per phase equivalent circuit?
Yeah, this is the
So
per phase
X1.
equivalent circuit. So X1 is given as 21.3
Okay.
and XM is given as 800 and then X2 is given as 21.5 and then this is R2 over S is V1 I1 this is I2. So we don't have to calculate I2 here even. You just have to find what is X equivalent and what is X2. So to find the X equivalent, so if you remember the class notes, so you have X equivalent like this. So this is X equivalent and this is JX2, this is R2 over S and this is V1. This is I2, right? So now you have to find X equivalent. What is X equivalent from here? So you can find the X equivalent, right? Basically nothing.
It's X1 parallel X.
Yeah, so this is X equivalent. So which is basically X1 parallel to X1. Is it clear? So I said I want to find what is X equivalent because if you find X equivalent, then you can find the S max directly. You don't have to do anything else. So X equivalent you can find it from here, which is X1 parallel to X7. So once you find X equivalent, you can add X equivalent with X2 to find R2 over S, and you have R2 known, so you can find S max. So you can find S max is equals to R2 over X equivalent plus X2.
So we were just doing magnitudes and should we go and make that phasor form?
This is already in phasor form. No, you are talking about the impedance.
Yes.
It's already in per phase, so you don't have to do anything.
So I don't need to do anything about the J's.
This one is just a magnitude, so there will be no J. That's what you do in impedance matching. You don't use a J here. So you just find the magnitude of this.
So just product over something like X1 and X.
X1.
Maybe yeah. I didn't try that, but what I did is I first used the J and did everything, and at the end I removed the J to make it the magnitude.
This is maximum torque happens when there's maximum power. And so that means we previously managed to find the point at which it's max power.
Yeah, exactly. Because yeah, tell me.
Just something in the book that I saw, there's a different notation for S max T and S max T, which is why I thought there might be separate.
That's max power
Yeah, yeah.
and that's max torque.
Yeah, but this would be
Because think about this. So what is torque? Torque is nothing but it's like 3 I square P gap is T gap over omega E, right?
yeah.
So to get the T max, you should have power maximum. To have the so how the sleep cannot be different for both.
Yeah.
But yeah, I can see the book. What is the book? So,
Could you go quickly just explain how you got rid of the jigs for it?
okay. So
You just get rid of it.
suppose we have x1 equals j1 and x2 equals j2,
Yeah.
and both of them are in parallel. This is x1, this is x2. So what is the total impedance? Total impedance is nothing but jx1 times jx2 over jx1 plus jx2. So this will be like j square is -1, and this will be 1 times 2 is 2 over j3, right? Which can also be written as minus, sorry, 2 by 3 j.
2 over 3 j.
Yeah. So to get the magnitude of this, you just remove the j, it will be just 2 over 3. Because it's just the imaginary side, you can just remove the j. But if you have something like a plus ib, like the full complex form, then the magnitude will be a square plus b square square root. But in this case, we just have the imaginary term, so it will be just L1.
Yes, so when we put it over r's under in the denominator of r squared, then we have it underneath another magnitude. So we
Yeah.
just multiply just like a regular magnitude.
Yeah, just the magnitude. So let's go to the next question. The starter voltage frequency is changed from 60 to 50 Hz. Okay, this is same as the homework. It's asking you that the frequency is changed. How will the x1, xm, x2 and r2 vary? Everyone knows this? Yeah, because x is the only thing which depends on frequency, right? So we can just write x1 dash over x1 is equals to 50 over 60. Then we can just find x1 equals 5 over 6 x1. So whatever the x1 is given in the previous question, whatever the x1 is given here, so if you multiply over 5 over 6, you'll get the answer. Do you understand why it is like this? Because in the exam we will not have the same question, we will have something else. Maybe you will have like 10 hertz or something, so
Do
you
you
should
have to do 5, 6 times every value or just x1?
No, you have to, because all the impedance depends on the frequency.
So you do 5, 6 times xm times
Yeah.
x2. Okay, all. Okay.
But not with the resistor, right? Not with the
Not
output.
with the resistance, because resistance doesn't depend on frequency.
So all of the reactive components.
Yeah, because
Okay.
what is x? X is 2 pi f into L, right?
Yes. Okay.
So that's why the frequency changes, so the x changes. So what is the next question? Compute the sleep.
No.
No, it's go back.
Oh.
You're up.
Down.
10%.
Okay, it's the same question as the previous one. As C, the only difference is you have new x. So this one is everyone is clear, right? How to find the x, the impedance if the frequency changes. So next question is compute sleep when the torque is maximum. So it's just the same formula we used, which is R2 over S equals X equivalent plus X2. Why we have this question? Because X1, X2, everything changed because of the frequency. So it's asking you to find the maximum torque, the slip at maximum torque with the new value of X. But the process is the same. If you understand the previous one, you can do this one. Is this clear? It says compute the speed in RPM at which the motor torque is 10 Newton meter. So it says the torque is 10 Newton meter, right? Newton meter. And if you see the previous question, the main question, even at 60 Hz, the torque is 10 Newton meter. So what does the torque depend on? Let's say the formula for torque. Torque is nothing but 3 I2 squared R2 over S over omega. Right? So we have two different torques, which is I can write torque 50 and torque 60. So it's 60 Hz is 50 Hz. So what will be the difference in this equation?
Omega.
There will be a lot of difference. So this will be slip.
Oh, yes.
Sleep will also be different. Like maybe different, I don't know. So sleep will be again sleep will be different, omega will be different, and the current will be different. Because you can write current I2 as V equivalent over R2 plus J X1 plus X2. X equivalent plus X2, right? So because it has impedance, this will be also different. Right? Am I clear? So now, what's the question? It's asking you to find the speed in RPM at which the motor torque is 10 km, right? So, how do we approach this question? So, torque is given as 10 Newton meter. This is 10 Newton meter. This is also 10 Newton meter. So what should be the slip for which the torque will be same? This is the same question as the homework, exactly same question. We had 50 Hz and 60 Hz and 60 Hz. So what did we do? We just find the ratio of these two and we substitute all the values. So for example, for this is I2 60 Hz, I2 50 Hz will be V equivalent over R2 plus J times, this will be 5 over 6 X equivalent plus X2. Do you understand why I wrote here? Because it's the reactance. We just calculated in the previous question, in this question, that each impedance will be like 5 over 6 into X, right? So that's why I wrote here, directly I wrote here 5 over 6. 5 over 6. And when you substitute everything in the equation, you'll find the value of slip, which is also equals to 5 over 6. So, okay, I don't know if you're confused with this question. So how to solve this question? So you substitute everything in this. So basically you'll have the torque is equals to, you'll substitute the I2 in this. So it will be 3 into V equivalent square over R2 square plus X1 plus X equivalent, X2 plus X equivalent square times R2 over S. Yeah, there is 5 by 6 here. And this is also R2 over S squared. And this is yeah, this will be R2 over S. Sorry. And this is squared times 5 over 6 squared. So you'll find the ratio of 50 over 60, and then you'll find for what value of slip you'll have both the torque as equal. Yeah.
Did you forget to divide by the speed?
Yeah, there will be a speed here. So it should be 1 over omega E times 5 over 6.
Okay, so it's a negative. Thank you.
So once you do the ratio, you have to find the value of slip for which the torque is same. Yeah.
For the torque formula, you just wrote u squared I, right? I2.
Yeah, this is the torque formula.
Yeah, but you substituted I2 in, right?
Yeah.
So don't you have to, when you square all the values in the denominator, don't you have to like FOIL it? Because you're just squaring all the values.
No. So this is what I did. So when you have I squared, that means you have magnitude of this squared. So what is the magnitude of this part? It's just R2 squared plus this squared, individual square root. Yeah. So because it's I squared here, the square root removes. That's why it's just this square plus this square. Is it clear? So this is the process how you do it. And the answer to this question is always speed will not change. Because this induction machine is torque controlled. If the torque is same, the speed will be same. So if you see here, the torque is 10 Newton meter. And in the question also is given that at the speed of 1120 RPM, the torque is 10 Newton meter. So that is trick. Like if you see the torque is same, so you shouldn't change the speed. It will always be same.
So we could just say, because the torque is saying the speed.
Yeah, you can say that too.
Just
Yeah.
put the number down.
But this is the process how you prove it, like if someone is asked for it. Okay, so last question. So this one says it's a 4-pole 3-phase Y-connected sequence machine, and it says the speed is 1800 RPM. The open circuit line to line voltage is 202 volt, and the field current is 2.02 amperes. The field current keeps the same, so it says IF is same, and when the generator is short circuited, the terminal voltage is 118 volt. Okay, let's first analyze the question. So first one, it says the open circuit voltage is 202 volt. So let's draw the equivalent circuit for that. So this is EAF plus or minus, and this is XS. It says the open circuit voltage is 202 volt. So this is 202. So what is the value of EAF if it's open?
202.
Yeah. So EAF we found it as 202. Then it's given that when it's short circuited, the field current is 118 amperes. So now we'll make it short. So this is EAF, and this is JXS, and this is short circuited. And it says this one is 118 amperes. So you have EAF, you have IA. You can find this reactance, right? Okay, what is the question? At open circuit, what is the peak value of flux linkage in phase A? Okay, the first question is asking you to find the flux linkage, which is lambda. So what is lambda? So what is V? Equals d lambda over dt, right? So it's d lambda over dt, right? So, or we can write it as j omega lambda. Because you can write d by dt as j omega. This is j omega lambda. So, if I want to find the magnitude of it, we can just write omega lambda. That's the magnitude. Or yeah. So it's asking you to find lambda. So what is lambda? Lambda is equals to v magnitude over omega. So you can find the v magnitude here, which is 202. So it should be 3 phase. So it should be 202 over square root of 3 times omega is 2 pi times 60. And okay, this is 202 volts, right? So this is line to line RMS, right? And I told you that this is peak voltage. So to find the peak voltage, so when you do 202 over square root of 3, that is per phase. But this is still RMS. So to make it to peak, you have to multiply it by 202 over square root of 3 times square root of 2. Yeah, once you start practicing more problems, you will be more familiar with this stuff. The next question is, what is the peak mutual inductance between the field winding and the armature phase winding A? It's asking you to find LAF. Mutual. So, what is EAF in terms of LF? We just wrote it here. It is omega times lambda, right? So we can write it as omega times lambda. We can write it as LAF IF. Because we know flux linkage is nothing but Li. So in this question, we already found lambda as, what is the value of lambda? 0.4375, 0.4. Four Webertons. So you know lambda, and I think the field current is given in the question.
You mean short circuit condition one? Is that what you're saying?
Yeah, 100 region.
Oh.
No, it's given here. 2.2. So IF is given. This is known. So you can find LAF is equals to lambda over IF. So you can use any formula. You can use this one, you can use this one. But this is much easier than this one, because in the first formula you have to, first thing is you have to find the peak value of voltage. Then you have the IF, but you just have to calculate this one again. So you can use any formula, but I think this one is much easier. Do it.
So I thought we already had our field. So IF is given, omega is given.
Yeah.
So is it like 0.2?
0.2.
So we can put check marks over the omega and IF for that EAF.
Yeah, if it's asking, you don't have to use this formula, but yeah, EF is given, omega is given, IF is given. You can find all that. Yeah.
It doesn't say what the frequency is, we just assume it's
60 hertz.
We just assume.
Yeah. If it's not given in the question, then the standard is 60 hertz. Or also you can find the frequency from here. It says 18 RPM, right? It says 18 RPM, 1800 RPM. So what is the synchronous speed? So 120F over P is 4/4. 4/4 is equals to 1800 RPM. And if you also calculate this frequency, it will be 1800 times 4 over 120. It will be 60 hertz. Then the next question is, what is synchronous reactance? So synchronous reactance, you can find it from here. It's asking you to find excess. So excess is what? Excess is nothing but EAF over IA. From this equation, it's asking you to find the synchronous reactance.
And I is just through the armature.
Yeah, it's the armature. So in this case, to find the what do you call that, excess, you can consider this as 202 over square root of 3 over IA is 118 amperes.
So use the short circuit current.
Yeah, you use short circuit because the question asks you to find the excess. So use any method to find this. So if you have this voltage known and this voltage known, then also you can use this circuit to find it. But we don't know this voltage. And in this there is no current because it's open circuit. So the only way to find it is by using a short circuit test.
Would you times the by the square root as well?
No, when you're finding the impedance, you always use the RMS value of the EA. But here I used the peak value because when you have j omega lambda, so when you want to find the peak value of this, it's just omega lambda. So this is the peak value of this. That's why we are finding the peak value of E here. But when you're finding the impedance, it's just RMS over current. When the field current is not applied, so IF is 0, only phase A of the armature winding has 60 Hz. Applied with a peak ampere of 1, and phase B and phase C is open, which is 0. The resultant peak flux linked to phase A is it's asking you to find the flux linked with phase A. So what is lambda? If I want to find lambda for A, it's just equals to the inductance with A times the current IA. No, IA is not 0. IA is given some reason, 1 amperes. So you have to just find LAA, then you can find it. So in the class notes, we proved one thing. So if we have L3 phase, this is nothing but L single phase, right? Just A phase. So L3 phase is known here. We found in the previous question LAF or LS. Okay, this was point. What is the value of this? 0.2. No, excess.
Excess.
Okay, excess is 0.98. 0.98. Right? Yeah. So excess is 0.98. So which means L3 phase will be 0.98 by omega. So this is how you find the L3 phase. and you know that L single phase is 3 by 2 times L three phase.
So it was 0.98? Like what value was that?
This value of the x's that we found
Okay.
here.
So the general formula should be xs over w, or omega.
Yeah, because what is x's? X's is nothing but or omega times L3 phase, right? Because 2 pi f times L3 phase, right? So from there we found this. Then we know that the L single phase is 1.5 times L3 phase. So this is nothing but you can say LA A0 because it's just for phase A. So now you found LA A0. Now we found LA0. Then you can directly find lambda A equals LA A0 times I. I is given as 1 amperes. So I is 1 amperes. And you found LA0 from here. So you can find lambda A. Any questions? Yeah, so this is nothing but when you transfer the three-phase impedance to a single-phase impedance. Because the question says we just use phase A, and phase B and phase C are open.
So what's the answer?
Yeah, there's one more question. It says the rotating speed of the machine. The rotating speed of the machine is 1650 RPM. To have the open circuit line voltage same as RMS voltage, which is 202 volts, how should the field current change compared to new field current? Okay, it's asked. Okay, this is the voltage given, and this is the rotating speed of the machine, which is reduced. So you know that I just wrote before. So EAF equals omega. Omega LAF IF, right? So LAF we found before, which is 0.2. And it says the speed reduces to 1650 RPM. So when the speed reduces, what is omega? Or what is frequency, F? Let's find frequency first. F is nothing but it is number of poles times the speed, which is 1650 over 120. Because we know Ns equals 120 F by P. From there we can find the frequency. So once we find the frequency, we can find omega. What is omega? Omega is equals to 2 pi F. So this F we found it here. So we know omega, we know LAF, and it says that field current doesn't change. How should the field current change? Okay, it says EAF doesn't change, it's the same. So how does the field current change? So before the field current, IF is inversely proportional to omega, right? Everything is same. LF is same, EF is same. So IF is inversely proportional to omega. So before the omega was more, so suppose omega 1 was 377, then omega 2 is reduced because the speed is reduced. So if the omega is reduced, the IF will increase. So that's the answer. So it says how the field current will change and compute the new field current. So to compute the new field current, you can take the ratio like IF1 over IF2 equals omega 2 over omega 1. So you know IF1, which is given the question, 2.2, you can find the IF2 from there. Any questions? So for the exam, I would suggest you to go through the homeworks, not like just go through it like just remembering it, but to understand how it is done. And also write down the formulas. Like at least you should remember what formula to use, so that when you get the exam, you can just find out the right formulas. And yeah, and just practice more questions.
Post these solutions. You post the solutions.
Yeah, I'll put solutions. And Dr. Fan said, if you attend the class and you understand everything, you won't be failing the class. So this is what she said. So she said, as long as you attend the class, you should be fine.
How she knows? If you ever attend the-
So does that mean she's just not gonna help out the people who don't attend the class?
No, it's not like that. No one knows who is attending, who is not attending.
Oh.
It's just like she expects that whoever attends the class, they know the basic concept, so they can do the problem. Because we don't know who is attending the class, who is not attending. So.
Yeah, I thought that's what she was like keeping track of that.
No.
It's like, when she goes to curve at the end of the semester, she goes, no curve for you, no curve for you. Even she lecture sucked.